All right, so yesterday we talked about parallel lines, and we also named that today we're going to spend time talking about perpendicular lines. And so if you remember, right, homework from yesterday has both parallel and perpendicular on it, and so this is going to be us sort of finishing up these two kind of joint lessons, if you will. And so the note page is going to be fairly identical to what we saw yesterday, only again, it's not parallel, they're perpendicular. So much like parallel lines, perpendicular lines behave in a very specific way. And so the first thing that we're going to do again is identify what do the equations of these lines actually look like. Now, the one thing we have to be really careful of in this graph specifically is our scale. We actually have not had an example like this yet. And so what I want us to be really careful of is that this would be 1 and this would be 3. And so every 2 boxes on this graph is 1 unit. Every 2 boxes is 1 unit, or every 1 box is half a unit. And so we want to keep that in mind as we're looking at slope, because I'm still going to start by drawing the annotation. Okay, well, here's my first line. There's the second line. And so my change in x right now, this is where I want to be careful. Raise your hand. What would my change in x be with this different scale? Amir? 1. Good change. We're moving 2 boxes, but because of the scale, that's really just 1. Our change in y then, we're moving, okay, 1, 2, 3, 4 boxes, but that's really only how many units because of the scale? Well, 2. Okay, so I know then my slope is 2 over 1, which is really just 2. And then I just need my y-intercept. And so let's take a look. This point's already marked for us. However, what is that coordinate point? T? 0, 3. All right, I've got my y-intercept. I've got my slope. Let's just name that 0, 3. Gives us a b value of 3. Let's be really specific. And so for this positive line right now, I have y is equal to 2x plus 3. We'll rewrite this down below. But for now, there's that. Okay, same setup. Now we're just going to do the other line. All right, I'll start with the y-intercept this time. It's right there. We can see, based on this, the annotation like already on the graph, this is 0, -2. We then go down, and then to the right. And so when I go down, that change in y has to be what type of a number? I heard it said again. Negative. So this is -1. Again, be really careful of scale. And then the change in x is 2. 4 boxes for 2 units. So that means that b is equal to -2, and slope is equal to -1/2. Which together means that we're going to have y is equal to -1/2 x minus 2. Okay, well, yesterday when talking about parallel, right, we mentioned that our slopes were the same. Let's take a just quick look. Are those 2 slopes the same? No. Okay. Which makes sense, right? Because if they were, and these were parallel, would we have this happen? No, right? When lines are parallel, or when slopes are the same, there is no point of intersection. So, from here, let's talk about what these look like. Again, we're going to split this up. And so on the left, I'm going to have what it looks like algebraically. On the right, we're going to talk about what it looks like graphically. So first thing I'm going to do is actually just rewrite the equations so that I can kind of look at them more closely. And so we have y is equal to 2x plus 3, and we have y is equal to -1/2 x minus 2. Now, when we talk about perpendicular lines, their slopes specifically interact in a very distinct way. Does anybody remember from last year, Gabby? Say it one more time. Reciprocal is involved. Reciprocal is 100% involved. I'll say reciprocal is half of it. Say that again louder. We also change the sign. And so the sort of wording that we use for this, opposite, reciprocal, slopes. These are opposite reciprocal slopes. Now, to me, like the easier way of remembering this is, as Gabby said, change the sign and flip. Right? This is really saying opposite, change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. And the reciprocal says, yeah, take what you have, flip it. And so you can see, right, our first slope of 2 ends up turning into, okay, well, it started as positive, so it needed to be negative, and then we flip it. 2 over 1 flipped, 1 over 2. Now, for perpendicular lines, we care much less about their b-value. They are 100% allowed to have the b-value because these lines intersect. So they are allowed to have the b-value be the same, or it could be different. Doesn't matter. What matters is the slope. And so now, graphically, this is, again, what you'll actually see on the graph. And so graphically, you'll see 2 lines intersect at a 90-degree angle. To be perpendicular, it means quite literally you cross at a 90-degree angle. And so this is a 90-degree angle. In fact, all of them will be, but you essentially make a perfect T, or X, or however way it's rotated. That is a perfect 90-degree angle. Any questions on notes so far? All right. Once you've got this, flip your notes so I can see, please. There, there. Okay, so example 1. Again, it's going to be really similar to example 1 from our notes yesterday. The big difference now is we're talking about perpendicular. We're no longer talking about parallel. So we see that line L is represented by y is equal to 1/2 x minus 3. Line T is perpendicular to line L. Okay, and so when we see perpendicular, again, we think opposite reciprocal slopes. Opposite reciprocal slopes. From here, I'm then given a coordinate point. Now, we talked about this at length yesterday. Raise your hand. Why do I know that this is not a y-intercept? T. Yeah, x is in 0. X is negative 1. And so this is just like some point. And so I'm going to label this x1, y1. And then I'm going to know that, okay, slope-intercept form. We saw this yesterday, right? This is y is equal to mx plus b. We also saw a preview of this on our do now, where we essentially did this skill. So my starting slope, I just circled it, is what, Prosper? 1/2. And so if my first slope is 1/2, that means that my second slope, let's start with this, Opposite, I'm going to go from positive, everybody, to negative. And then I'm going to flip it. If I flip 1/2, raise your hand, what number do I end up with? T. -2. And so when I create line L, the slope has to be -2. And so I'm going to have y minus 4 is equal to -2 times x minus a -1. Let's clean up the double negative. Everybody, double negative turns into a... Ooh, I want more voices. Everybody, double negative turns into a... Okay. And so y minus 4 is equal to -2 times x plus 1. Awesome. Am I done? No. Raise your hand. What do I have to do now? What do I actually have to do with this now? Amir. Say it again louder. Distribute. I want to distribute because I need this in what form again, Gabby? Slope intercept. It is plus 1. Yep. Y minus 4 is equal to -2 times x plus 1. So, distribute in the 2. And I'll zoom in. And so y minus 4 is equal to -2x. Oops. Minus 2. All right, from here, just like the do now, we're one step away. What's the last thing we got to do? We'll say it again loud. Add 4 to both sides. And so y is equal to -2x plus, -2 plus 4 should give me what, T? Positive 2. There is a line L. Y is equal to -2x plus 2. Any questions on example 1? All right, rolling right on through. Gonna finish these out. All right, example 2, line K. This is the same line K that we saw in our notes yesterday. The difference now is perpendicular. And so again, we see perpendicular. We think what? Opposite reciprocal. And then here's x1, here's y1. Now again, because I need to know the opposite reciprocal, I have to find the starting slope. And so, okay, we're going to go down, and we go to the right. Now, because I go down here, my change in y should be negative. Specifically, we're going to have -3. And then I go to the right, so my change in x should be positive, specifically positive 4. Our slope, our starting slope, is going to end up being -3/4. That means that my perpendicular slope, raise your hand, should be what, Gabby? Louder. Positive 4/3. Again, whatever sign you start with, change it. Take the fraction or the number, flip it. Truly all there is to create that perpendicular slope. Okay, well from here, I have slope, I have x1, y1. Let's plug these in. Y minus -5 is equal to 4/3 times x minus 4. Clean up the double negative. Y plus 5 is equal to 4/3 times x minus 4. I do not have to take this further because they are not asking me for a specific form. I get to stop right there. What questions do we have about notes today? All right. Fold these, get these glued in, and then we're going to start with some practice. But you got 1 minute right now. 1 minute. Go.